Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this Milwaukee Tools battery charger. It is for the batteries the M12 and the M18. So let's get started. Now taking a look at this charger, we can see that it is still brand new and there is no scratch in it. That is really nice. Now, according to the owner, he received this charger with its new cordless drill, and when he tried to charge the batteries, he plugged it to the wall socket, and then the magic smoke came out of the ventilation grill. Now, our voltage or our grid voltage, it is a 220, and if we take a look at the information, it is printed in the label of this charger. We can see that the input voltage, it is a 120 volts. It runs on 60 hertz and it consumes 2.1 amp. The output voltage, it is 12 and 18, and it produces a 3 amp of power. So let's open it in order so we can see what's wrong with it. Now, in order so you can open this setup, you need to remove 4 screws from the bottom, and these are the screws, 4 from the corners, as we can see. And I used my hex tool set, star shape, and the T10, it is what size you should use. Now, taking a look at the circuit board itself, we can see the problem, and I believe this is the Viresta. The part number of this, it is the 10,271. It is a TVR. So definitely when the Viresta it is blown, the fuse it is blown also. And taking a look at the rating of this fuse, I don't know if you can see it on the camera, but it is a 3.15 amp, 250 volts. If I just zoom in, maybe you can see it. No, the writing or the printing on this fuse, it is very shallow. Yeah. Anyway, so what I'm going to do, I'm going to remove this board from its place and do a thorough examination for all of the component and the input of the power lines. Test the capacitors, test the IC. Now, I believe it is an IC. Yes. What an odd looking IC. Shopper driving IC. Wow. I don't like the blackness behind the IC itself. Don't know if the IC it is blown or not, but after the testing we will confirm that it is, if it is survived or not. So yeah, a lot of elastic. So yeah, so let me pause this and do a thorough examination, and then we will continue from there. So after I did a thorough examination for all of the component in the shopper circuit, it turns out that the two these two components, they are the one that they are shorted and blown: the fuse and the viristor. The bridge rectifier diode, it is okay, and according to the testing also the shopper IC, it is also okay. So what I'm going to do now, I'm going to find a replacement of these two parts, and then I will install them and hope that this charger will work like it should be. So here is the new fuse and also the new virista. They are installed and soldered into their places in the circuit. And as we can see, taking a look at the virista that I choose, this one, it is different from the original one. The original one, it has a clamping voltage up to 175 volts. This one, it has a clamp of a 170 volts. Now this virus, it is not brand new. It is used, and I pull it out of a Sanyo cordless phone board. But it should work just fine for this application or in this circuit. Now I'm going to feed this with power from my bench power supply and set the current to a half amp in order so we can monitor this thing closely and see if it will work correctly or not. So here we go, let's plug it in. Everything seems okay. Here we go. Everything seems just fine, and this circuit, it is drawing around 230 milliamp. The surge, it is up to a 700 milliamp. That is really good. Now I'm going to connect some tabs in order so we can test the voltages with the DMM. Here we go. So I soldered two resistors and I use the pins of them in order so I can connect the probes of my DMM, and now I'm going to power this board up in order so I can see what kind of voltage that this board it is going to produce. As we can see, we have a voltage, it is present and it is in the millivolt range, and that is from a previous powering up. Here we go. Once I plug it in, we can see that there is an 11.04849 and it is climbing. That is really good. This tells me that the shopper circuit, it is working, and also the output of the shopper transformer, it is also working. There is no heat, and this is very good news. Now 11.056, as we can see, 57, it is good voltage for a charger without a battery. The only way to see that this charger it is working correctly or not is to desolder these two resistors, assemble the entire thing and connect a battery. And this is what I'm going to do in order so I can confirm that this charger it is working correctly or not. So let me do all of this and we will see what will happen. So I installed the charger board into its place in the cabinet and I close it up without putting the screws into their places, just so I can test this thing and see if it will work correctly or not. So here we go. Here is power, it is on or plugged in. Here is the battery. Let's plug it in. As we can see, we have a red light in this port, and this means that the charger it is charging the battery. I'm going to leave it for about 2 maybe 3 minutes, and then we will see how this charger will behave. So here is 3 minutes, it is past, and the charger, it is still charging the battery without any kind of problem or without any kind of abnormal heat, and that is really good. This tells me that this charger, it is working and working correctly. Now all what I have to do is to remove the battery, disconnect the charger, put the screws into their places and secure them tightly, and this charger, it is ready to be delivered to the owner. So in the end, I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.